So we learned how to use the trig identities and to find the sides and the angles of a right triangle. But we're going to solve oblique or non-right triangles. An oblique, O-B-L-I-Q-U-E, an oblique triangle is a non-right. And there are two different ways that we can solve oblique triangles. There are 4 cases of triangles, but today we're going to look at the law of sines, and then we'll look at the law of cosines next week, which is another method that we can use to solve triangles. Now, there are 4 cases for oblique triangles. You could use angle, side, given that information, or maybe
We did this.
angle, side, angle. Does this sound familiar? Yes. We're going to approach it a little bit differently this time. This means that you're given 2 angles and 1 side. That could be the given information. 2 angles, 1 side. Okay, you could have 2 sides and an angle, even though that was not a theorem that we could use in geometry to prove congruent triangles. We could have 2 sides and an angle that's opposite one of them. We can use the law of sines. 2 sides. Okay. There's a case when you could be given 3 sides.
Wait, what does that say? It says opposite.
One of them, one of the sides. And then we could have side, angle, side. This is 2 sides and an included angle. For some you use law of sines, for some you use law of cosines. And we're going to, for the first 2, we're going to use the law of sines. And it's one that is extremely easy to remember. There's not much thought process that has to go into memorizing the law of sines. Remember, with a triangle, a small letter indicates the side, a capital letter indicates the angle. So the law of sines says that side A over the sine of angle A is equal to side B over the sine of angle B, which is also equal to side C over the sine of angle C, or the reciprocal. Depending on what information you have and what you're looking for, you might want to use the reciprocal form. And I think you can see why you might need your calculator today. Sine, not side. Okay, so there's your law of sines. Not a hard one at all to remember. Law of cosines will take a little bit more effort. But this one is an easy one to remember, so let's just, yes, sir?
So when it's comparing side A to angle A, that's the angle opposite of the side?
Yes. The side A is always opposite angle A. Side B is opposite angle B. Good question. Okay, so let's look at an example of how we would use this. If you were given that angle C is 102 degrees and angle B is 29 degrees and side B is 28 feet, I want to solve for the unknown sides and angles. Now I'm going to draw a triangle. It's not drawn to scale, obviously, but if angle C is 102, we know it's more than 90. So we'll just say that this is 102 degrees. Angle B is 29 degrees, and we know that side B is 28 feet. It's always a good idea just to sketch your triangle. And it wouldn't have mattered had I switched where angle A and angle B are. It doesn't matter. But you just have to be sure that side B is opposite angle B. That's what's important. Okay, can we easily find angle A? Do we need a new formula to find angle A? So how would we get angle A? Add and then subtract from 180? So angle A is basically 180 degrees minus 102 plus 29. So angle A is 49 degrees. So that was easy. If you are given two angles, it's always easy to find a third angle. Not much goes into that. Okay, so now I need to find side A and I need to find side B. Since we already have our angles situated, we can do that pretty easily. We know that A over the sine of 49 is equal to 28 over the sine of 29 degrees. Okay, now again, be sure that you are in degrees, not radian measure. In fact, I need to check my calculator because we go back and forth, because I am in radians. Okay, so to find A, we're going to multiply both sides by the sine of 49 degrees and then divide by the sine of 29 degrees. And what did you get? Hopefully 43.59.
Yeah.
What was that? 43?
43.59. And you can then do the same thing to find side C. Side C over the sine of 102 is equal to, use your given, don't use that one you just got, use the given information, 28 over the sine of 29 degrees.
Bless you.
So C equals 28 times the sine of 102 over the sine of 29, which is approximately 56.49 feet. With the law of sines, if we are given a side, and an angle, we have what we call, this is an ambiguous case. Notice you only have one angle. Anytime you have one angle, we have to check a little bit more. It's called an ambiguous case. There are three possibilities, three possible answers. You could have one triangle, you could have two triangles, or you could have no triangles. Now, the book goes through a whole rigmarole. I think it's easier just to check. I'm going to show you the way I do it because I think it's easier than trying to learn a formula to figure out whether there's one triangle, two triangles, or no triangles. So let's just look at our situation. If I tell you that side A is 22 inches, side B is 12 inches, and angle A is 42 degrees. The first thing that we're going to have to look for, since we have side A and side B, is angle B. And since we're looking for the angle, we might want to use the reciprocal of the law of sines. In other words, the sine of 42 over 22 equals the sine of angle B over 12. So 12 times the sine of 42 over 22 equals the sine of B. All right, so if we plug that in your calculator, you're going to get 12 times the sine of 42 divided by 22, approximately 0.3649, but that's the sine of B. How am I going to figure out what B is? What do we do? If we know the sine, how do we figure out the angle? Arc sine. So on your calculator, second sine, second answer. And you should get that angle B is approximately 21.4 degrees. Now, the reason we have to check here, think the sine is positive in what two quadrants? 1 and 2. And 1 and 2 are both less than 180 degrees, aren't they? So it's possible that there could be two angles for this triangle for angle B, because the sine here gives us 21.4 on our calculator, but we also know if we subtract this from 180 degrees, there's another angle that has the same sine. So what we're going to do is check to see what happens if we subtract. So this is our possibility. This is our check. We're going to check. And we're going to subtract 21.4 from 180 degrees. Okay, and when we do that, so we don't have to think too hard, we get 158.6 degrees. Okay, so just based on the sine, there's two possible angles for angle B. Either this first quadrant, acute angle, or that second quadrant, obtuse angle. But we've got to check what happens if I add my original angle to 158. Do we get something that's more than 180 or less than 180? Okay, because that's more than 180 degrees, I have one triangle. I just checked it, I have one triangle, so I just proceed. If I've got angle B and angle A, can we find angle C?
Yes.
Angle C is 180 degrees minus 21.4 plus 42, or angle C is, I'm letting y'all put on your calculators. Okay, so angle C is about 116.6 degrees. So there's my obtuse angle. Now can we find side C? I have side A and side B. Can I find side C?
Yes.
Okay, so we know that C over the sine of 116.6 is equal to, let's use our given information, not the angle we found, but the angle we were given. Keeps it a little bit more accurate. And C is approximately, what'd you get?
32.8. I got 29.39.
I got 29.4 as well. Are you sure you're in degrees? Okay, A is 15, side A is 15, side B is 25, and angle A is 85 degrees. All right, so we have to look, and if you want to draw a triangle to label everything, that's not always a bad idea, and it doesn't have to be drawn to scale. This is angle A, this is 15. If this is angle B, then this side is 25, and we don't know what side C is. Okay, so we're going to try to see if we can figure out what angle B might be. So we know that we've got the sine of b over 25 has to equal the sine of 85 over 15. So if you multiply 25 times the sine of 85 and divide that by 15, what do you get?
Sine B.
Minus 85, yeah.
What number do we get?
1.66, no, actually 1.7.
Okay. So 1.66, well, I got 03, but,
Yeah.
okay. Right now, you should be able to tell me something.
It's over 1.
It's over 1, so it's not possible. There's no solution. There is no triangle possible that has these dimensions. It's not possible.
Is that because whenever you do arctan can't be over 1? I mean,
Arcsine, yes, arcsine cannot be over 1. The sine cannot be more than 1.
Okay.
And if you do second sine, second answer, you're going to get an error. That's why you get an error, because sine can't be greater than 1. Yes?
Why can't sine be greater than
Because our range for the sine is between -1 to 1.
1? Okay.
Okay, so that's a case, if you get an error, or if you get a sine greater than 1, you know that that's a triangle that has no solution. Those dimensions will not work for a triangle. Side A is going to have to be bigger than side B in this case because of the size of angle A. But on your calculator, you just see you get the sine greater than 1, so it's no solution. There is no triangle with those dimensions. Okay, and I think probably before lunch we have time to do a 2-solution triangle. Okay. Side A is 12 meters. Side B is 31 meters. And angle A is 20.5 degrees.
Oh.
So I'm going to have to find angle B. So the sine of angle B is over 31 is equal to the sine of 20.5 over 12. So the sine of B is 31 times the sine of 20.5 divided by 12. So if you put it in your calculator,
0.9047.
0.9047, and so that's the sine of B. And if we do second sine, second answer, B is approximately,
64.7.
okay, I'll go ahead and do 2 decimal places. I don't remember what the instructions in the book are. We'll just do 2. Okay, so there's 2 angles that have that particular sign. One of them is in the first quadrant, or I'm going to draw a line. We're going to see B could also be 180 minus 64.78. Which is 115.22. Okay, if I add 20.5 degrees to that, am I less than 180?
Yes.
So I have 2 triangles here. This one is a 2 triangle. So we do left side, right side. Okay, so on the left side, we've got 2 angles. I can find angle C. Angle C is 180 minus 20.5 minus 64.78, and that's 94.72 degrees for angle C.
Wait, so C is 180 minus
The two given, 64 and
plus-
20.5. And now I just need to find side C. So C over the sine of 94.72 is equal to, let's use our given information, 12 over the sine of 20.5. So if we type that in, you get approximately 34.15?
Yes.
All right. Now we go and do the same thing with the other
Wait,
possible angle,
what was it?
34.15. Okay, so if this is angle B, angle C is 180 minus 115.22 plus 20.5. $44.28. And then you can find side C here. C over the sine of 44.28 degrees is equal to, again, use your given, 12 over the sine of 20.5 degrees. And then it's just a matter of typing into your calculator.
Is it 23.12?
23.92 is what you should get. Now, I'll usually draw a line, work on one side for one triangle, work on the other side for the other triangle.